In this video, we will be seeing how to create an attrition table. Attrition table is something, it's a table where there are multiple steps, and each step we apply a filtration criteria, as a result of which we lose a certain number of subjects that doesn't fit that criteria. So with every next step, the number of patients keeps dropping down. For example, when we look at the total number of patients in the data set, and then we apply a filtration criteria, say age greater than or equal to 18, then we lose patients who are less than 18. Then if we apply a set of condition like the patient should have a certain diagnosis, then again we will be losing patients who do not fit that criteria. So with each step, then we may lose a certain number of patients. Or maybe there are certain situations where we may not lose also. Maybe all the patients in the database are 18 and older. So if we are filtering patients who are less than 18, then we may not lose any patients if we don't have any patients who are less than 18. So that is attrition table, and it has many steps. Here we'll be looking and we'll be getting the total number of patients, listing patients at each step, and also the percentage. The programming language we'll be using is SQL. See, SQL is the most common language that is used to query database. In most of the times, we may be working on SQL interface, and we this is the common trend in the industry where most of the data is in the cloud platform. As I discussed already in the previous video about RWE introduction, what is real world evidence, real world data, how they are different from clinical trials. And there also we just touched upon the kind of tools we use in the industry. And SQL is very common. So it's very important to learn SQL. And we can also see how to use other tools like R or Python or SAS in addition to SQL. Now that we know what attrition table is, now let's look at each step here. So the first step is we are looking at the total number of patients in the database. And the indication that we are focusing on is prostate cancer. Cancer that forms in the prostate gland is called as prostate cancer. The second step is MCRPC diagnosis. MCRPC is metastatic castrate resistant prostate cancer diagnosis between 2016 of January 2016 to December 2022. So first it's year, month and day. When you see 2016, 1, 1. So what is MCRPC and why we are looking at this particular duration of time, but that is 2016 to 2022. Now, MCRPC is, as we said, it is metastatic. That is, it no longer is confined to prostate gland. It has spread beyond the gland to other areas of the body like pancreas, lungs, liver, etc. That is what metastasis means, metastatic. And castrate resistant, usually uh, the growth of the prostate cancer growth is fueled by androgens like testosterone. So that is usually that's how it happens in the initial stage, and then testosterone levels are reduced, and this helps to control the growth of the cancer. But at a certain stage, when this treatment doesn't no longer affect the health of the patient, but the cancer still continues to grow despite reduction of androgens, androgen deprivation therapy. Despite that, even the cancer grows. That's what we call as castration-resistant prostate cancer. And this androgen reduction is not just by reducing this testosterone that is done using surgery or medications. Surgery involves removal of testicles. So when cancer no more responds to this treatment, then it's called as castrate-resistant prostate cancer. So in the second step, we are looking at patients who are metastatic castrate-resistant prostate cancer diagnosis. And there is a time period given who have been diagnosed of MCRPC between 2016 to 2022. This time period is called as index date, index identification date, or index period also we can say. So there may be patients who have been diagnosed of MCRPC even before 2016, but we will not be considering them. We will be only considering those who are been identified with this condition within a period of time mentioned here. That's because actually maybe that particular, often actually we see actually index statements where the patient may have started a particular treatment during a period of time, or maybe may have been diagnosed of a disease condition over a specific period of time. That specific period of time is called as index date. Why do we need an index date? It's because maybe a certain drug was already there in the market, but its use in a specific disease condition. Maybe it was used for some other condition, but gradually there was a label expansion and the drug became available for another indication as well. And that's so we don't look at patients who were treated with this particular drug or who were diagnosed before this period of time, because that particular because we were not those drugs were not given to those patients for that particular indication we are interested in. So now that we know what is index date, index period, and index date may change from study to study. So in some study it may be starting of a particular drug. In some studies it may be initial diagnosis of a disease condition like let's say cancer. In some other condition, some other study it may be it can be advanced diagnosis or a progression of a disease condition. So it keeps changing from study to study. So this may not we have to look at the study protocol or analysis plan and decide what exactly is the index date for that particular project. Then we also have something called study period. So every study has a study period usually where we will have a start date and end date and within which we will be using the data. So since here actually we are looking at the diagnosis, MCRPC diagnosis, the index date. And when we are looking at the study period, it is actually looking at the all the as all the other data sets, all the tables when we are using only within the study period. Whereas when we are looking at MCRPC diagnosis, we are only considering the diagnosis table in the particular database, not the lab data, not the vitals data. But when we are looking at study period, we are considering all the date tables that will affect all the tables. We will see more in detail what exactly how we are ensuring that we are collecting data only within the study period. And the third step here is age greater than or equal to 18 years. And the fourth one, excluding other primary malignancies. So there may be other set of diagnoses that we are not interested in, and we wouldn't want our cohort of patients to have those set of diagnoses. It can be anything, any set of diagnoses. So those kind of diagnoses has to be excluded. All those patients who have other malignancies have to be excluded from the study. Then fifth one is exclude clinical trial enrollment. Some patients in the database, the real world data, may have enrolled in a clinical trial, and if there are any, we will be excluding them as per the requirement of the study. And there are six steps is exclude less than 30 days follow-up. If any patients have less than 30 days of follow-up after the index period, that is after the diagnosis of the disease condition, which is the index date is the MCRPC diagnosis. After that, we should make sure that the patients have at least 30 days or more to follow-up days. So if those patients who don't fit at least 30 days of follow-up are excluded from the study. So this is about the attrition steps and the attrition table that we are going to create using SQL. We can also see with other tools as well. So for now, in this particular video, we'll be starting with SQL, and gradually we'll see how we can apply other tools as well for perform the similar steps. Now let's go to SQL interface. Here I'm using SSMS. SSMS stands for SQL Server Management Studio. So it's basically a free version of a SQL platform that anybody can download and install in the system and use it. If you want to download, you can go back and check online any videos that will have installation guidelines for SSMS, SQL Server Management Studio. And where I mentioned about study period and the index date identification period. So study period usually is longer than it's it will be longer than usually the index date identification period, because we want to give some time for follow up also. So index data identification period will be a will be a subset of the study period. Now in SQL, you can see this is the interface, SSMS. And here I'm mentioning use F5, since this is an example of flat-end database where we are looking at exploring the data. That's why you can give you can, whatever library you are creating, you can mention that. So I'm mentioning here F5 is the schema that I'm interested in. If any of you have worked on SAS, then you know we call it libraries in SAS. So those that particular schema here, F5 schema, has all the tables of flat end, and using this statement will make sure that you see, actually initially it's mentioned as master, this is a default, but the moment I run it, automatically this will be changed to F5, the schema that I'm interested in, where the tables of this project are located. So now you can say it's changed to F5. You can give any name here when you create the schema. Initially, I start with the declaration or initiation of the variables that I'm going to use. That is standard for me throughout this session or the project. So this entire script or the session, this will be stored. But make sure that you're running all at a time. If you're running part by part in batches, then this will throw an error, because it will not be considered. It will be, we have to run in the same batch, then only these particular values will be taken into consideration when we do all the analysis. So what exactly are we doing here? We are creating a value for start date as January 2016, which is the study start date of the study period, and also the start date of the index date identification period. And this creates a variable called, we can call it, initializes actually start date. It creates a memory space for the variable called start date, which contains this particular value. Those of, if you have worked on SAS, then you know that it's like a macro variables that we create. But there is a difference here between macro variables that we use in SAS and this declaration of variable start date here. And we'll see how they are different also. Next, we have index date end date. This is the index date end date, identification period end date, index date identification period end date. So we have study start date and index period end date. I'll just mention here. So this is the starting is the study period start date, also the same as the index period start date, where we are looking for MCRPC diagnosis. So this is the same. Next is we have the index date end date here. This section, this point, actually I just put as 2, and a third is the study period end date. So we are giving a certain amount of time for follow-up also between the index date identification period end date and the study end date. I think this could have been better to put this in the last. This in how we declare variables in SSMS SQL. And now let's see how we can do the same in SAS environment. In SAS, we can declare variables. It's also called as macro variables. and here it's a start date. So simple statement allows us to do that. Person let start date equal to 1 Jan 2016. I mean, even if we don't have to mention this, when quotation is not needed, so I have removed the quotations. It's basically you can just pass it within quotation when you're referencing the macro variables and with a D so that it understands. So basically, in order to understand how to declare a variable, it's very simple here. Using person let statement, we can declare the variables. Start date equal to 1 Jan 2016, IDX end date equal to 31 December 2022. The same values that we passed in SSMS. And whenever we want to print the value, basically we reference that value using ampersand. It's called ampersand and the same variable, start date. So when you basically you create a value here using this person let statement, and this is calling the value. Basically, you're calling using adding an ampersand before that variable name. So that's one extra ampersand here. So that's only difference. So creating a variable and then this step is calling the value. Person put means basically printing it, printing the values for those variables. And I'm sorry, it should not be, it should be start date. I just realized the variable names were incorrectly printed. So basically this person put tells us to print the value for the start date. And this particular value gets printed. We'll just see how it, when we run it, we can see the results as well. So you can see start date equal to, this is the variable name and its value is equal to 1 Jan 2016. Same for the remaining two variables. So total all these three variables have been printed in SAS environment in the log window. This is a log window. This is a code environment where you write the code, and this is a log environment where these values are getting printed when you write person put statement. So person let statement for creating the variables and person put for printing the variables. And then there's a result environment as well, where if you are printing something, it will printing. Let's say you want to print some data set that is already there in the SAS environment, then it will be printed here. So let's say you just want to, this just like printing a data set. There's a data set, it's called sashelp.class library data set, which is inbuilt in the SAS help.library. There's a library called SAS help, which contains some inbuilt data set, and class is one of those data sets. And prop print is a print procedure that prints this data set. So I just want to tell you what results window is, but you don't really have to go in detail about it because the main focus is how to declare a variable here. So this is the results window where the results get printed. So there are three windows here basically in this area, and then apart from there are other as well where we have libraries and etc. But this just like printing a data set. There's a data set, it's called sashelp.class library data set, which is inbuilt in the SAS help.library. There's a library called SAS help, which contains some inbuilt data set, and class is one of those data sets. And prop print is a print procedure that prints this data set. So I just want to tell you what results window is, but you don't really have to go in detail about it because the main focus is how to declare a variable here. So this is the results window where the results get printed. So there are three windows here basically in this area, and then apart from there are other as well where we have libraries and etc. But this just like printing a data set. There's a data set, it's called sashelp.class library data set, which is inbuilt in the SAS help.library. There's a library called SAS help, which contains some inbuilt data set, and class is one of those data sets. And prop print is a print procedure that prints this data set. So I just want to tell you what results window is, but you don't really have to go in detail about it because the main focus is how to declare a variable here. So this is the results window where the results get printed. So there are three windows here basically in this area, and then apart from there are other as well where we have libraries and etc. But let's just restrict our understanding focused on how to print variables and how to assign a value and print them. Next, we'll see how to do the same in R environment. So here is the R environment where we have created a start date variable, ID, extend date, end date, those same variables. And we can see this assignment operator, this arrow mark is assignment operator. Basically, we are assigning the value on the right to the variable on the left. And why we are giving as dot date? Why don't we just assign simply the value for the date? What's the purpose of this function as dot date? If we don't give this function, it will be the value of date value will be treated as a string, a text, and we cannot do any operations on it. Let's say you want to add 30 days more or 30, let it subtract 30 days from the date value. Those operations can only be performed if it is treated, if this particular variable, if this value is considered as a date by R. So in order for it to be treated as a date, this function is mandatory. It's very important. Now, this is the, I think it's self-explanatory how to print it, print the same values. In SAS, we saw percent put, here it is print. And if we run this, we can see this date value is printed. I just printed 2 times. So it's otherwise you can just look into these 3 values being printed here: start date, ID, extend date, and end date. Now let's come to Python. In Python, we are using a library called pandas, and PD is the alias for it. Is shortcut name for it. So once we import this library, then we can assign the value for start date and those variables using pd dot date time. PD is the library and date time is to date time is the function. We are calling from the PD library, which is pandas library. And again, we are assigning converting it as a date value. And you see here print similar to R. We are using print function for the start all these 3 variables. Here extra thing we are adding is start date text as well. We are adding a text as well for it to print.